believe I did that. Got to turn it on. Okay, so how many people did you say they're all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 people. So the probability of picking someone who has less than 2 vowels would be 2 over 13. Pat and Bob are the only ones. Okay? So Venn diagram included entirely within another Venn diagram. Here would be another example of that. Here are my siblings. I'm just going to put down their first initials. So I got Eric, Mark, Robin, Rhonda, we'll just call her H, and Leslie. Those are my siblings. My sisters are Rhonda, Robin, and Leslie. Okay, those are my siblings. So if I built a Venn diagram consisting of my siblings and my sisters, wouldn't my sisters be inside the siblings one? So my sisters, Rhonda, Robin, and Leslie, would be inside the sister circle, but Mark and Eric would be out here inside the sibling circle. Okay? All right. They're all siblings. All of them are siblings, but the sisters are special. They're in the sister circle. That actually happens a lot. Think of if you had, like, this is the teachers in the school, all the teachers in the school, and this is the math teachers. Wouldn't they be entirely contained in there? Yeah, that happens a lot. Okay. Now, a box contains these pencils. We're going to pick 2 pencils, and we want to know what's the probability they'll be the same color. So, got to keep track of this. There's 5 red, 6 blue, 7 orange. You are going to pick a pencil out of the box. Reach in. Oh, here we have a beautiful illustration here. We're going to reach in and grab a pencil out of the box, okay? Now, what can happen if the box only contains red, blue, and orange? Then I'm either going to get a red one, a blue one, or an orange one. Would you agree with that? Now, how many pencils are in the bag? 18, right? So the probability that I would get a red one would be 5 18ths, right? And I get a blue one would be 6 18ths, and I get an orange one would be 7 18ths, right? So I have reached in the bag and pulled a pencil out, and I've laid it on the desk. Now, how many pencils are left in the bag? 17. So for round 2, remember I'm picking 2. So for round 2, my probability is going to be over 17, because now I only have 17 to pick from. Okay? So I have reached in and grabbed a pencil and put it on the desk. Let's pretend I got a red one. Okay? So now I'm going to reach in and I'm going to get another pencil, and it is going to be red, blue, or orange for my second draw. Now, if the first one I pulled out was red, then there aren't 5 reds in the bag anymore. There's only 4 out of 17. So this probability would be 4 out of 17. Because I already took a red one out and put it on the desk. Now, what about blues? If I took a red one out, how many blues are still in the bag? 6 out of 17. And the oranges are 7 out of 17. So that's what's going to happen if the first one I pulled out was red. Well, what if the first one I pulled out was blue? Are there still just 17 in the bag? Okay. Now I pulled a blue one out. Now blue one's here. So how many reds are left? 5. How many blues are left? 5. And 7 oranges. Now what if I pulled out an orange first? I can still get a red, a blue, or an orange on my second draw. There's still 17 left. But I pulled out an orange. So how many reds are left? 5. How many blues are left? 6. And how many oranges are left? 6, because I pulled one out. Now luckily, we are only pulling out 2 pencils, so we've done that. So each of these little branches represents an outcome. This says you got a red one, and then another red one. This says you got a red one, and then a blue one. You got a red one, and then an orange one. See how it works? Now, what do we want? We want to get the same color. So if we want to get the same color, that means we want red, red. Would you agree with that? Or we could get blue, blue. Or we could get orange, orange. So, blue, blue, or excuse me, red, red. This is red, red. The probability of one red is 5/8. First red was 5/18, and second red was 4/17. We're going to multiply those two numbers together. We want red and red, so we're going to multiply those together. Whenever you want X and Y, you multiply it. So we want to get a red and a red. I know that reduces, but I don't want to. You'll see why in a second. So what's 18 times 17? Would someone do that for me, please? 18 times 17? 306. I know it reduces. Just hang on and you'll see why I'm not. I'll reduce my final answer. All right, so that's the red, red. Now let's do blue, blue. Same idea. Blue, blue is going to be 6/18 times 5/17. Everybody see that? And that's 30 over 306. And then we're going to do orange, orange, which is 7/18 times 6/17. Or 42 over 306. Now I can get 2 reds, 2 blues, or 2 oranges. What is the total probability of that happening? What do you think I'm going to do with all these individual probabilities? Since it could be that, or that, or that, how do you think I'll find the total? Add them up. Add them up. And that's why I didn't want to change them, because if I leave them like this, what do they all have? The same denominator, right? Which makes adding them easy. So the probability of getting the same color is going to be 20 over 306 plus 30 over 306 plus 42 over 306. Which is 92 over 306. Now that I will reduce because that is my final answer. So I'll go ahead, whoops, don't do that. Go ahead and reduce. 46 over 153. So the probability of getting 2 pencils that are the same color is 46 out of 153. All right, now, second question. Probability of getting one red and one blue. One red and one blue. Well, where does that happen on the chart here? One red and one blue. Would that be right here? Would that be a red and a blue? And I think it happens somewhere else. Right here? Because what's that? Blue and then red. So I can do that two different ways. I can get blue and red or red and blue. So that probability will be 30 over 306. Remember, we're multiplying. And this one, oh, is that also 30 over 306? This times this. So what's the answer to the question? 60 over 306, we're adding those together, and that reduces, I'm sure, 10 over 51. So the probability of getting one red and one blue is 10 over 51. Okay, so let's make sure that we're all on the same page here. Some of you look very, very bored. I think this is exciting. When we are finding the probability of a branch, so like blue and red, we multiply those numbers. When we are finding the probability of either this or this or this, we add those. So we multiply along the branches, each individual branch, we multiply. But when you have more than one possibility, you're considering two blues or two reds, you add them together. Okay, got it? If you're doing this and this, you multiply. If it's this or this, you add. All right, next, it's raining. If it rains, the probability that Hunter does his homework is 72%. If it doesn't rain, he does his homework 12% of the time. The probability of rain is 47%. Find the probability he'll do his homework. What does it kind of all hinge on? Whether it rains or not. So let's start with that. Tomorrow, it is either going to rain or it's not going to rain. That's what's going to happen tomorrow. What is the probability that it's going to rain? 47%. And if the probability it rains is 47%, then the probability it doesn't rain would have to be, what? 53%? Does that make sense to everybody? Rain, not rain, adds up to 100. So, it's either going to rain or not rain tomorrow. And then, Hunter's either going to do the homework or he's not going to do the homework. Now, if it rains, what is the probability that he will do the homework? If it rains, the probability is 72%. It tells you that right there in the problem. If it rains, there's a 72% chance he'll do the homework. Then what's the probability he won't do the homework? 0.28. Now what if it doesn't rain? If it doesn't rain, then his homework probability is 12, which means his not homework probability is 88. want the total probability that he will do his homework. So does everybody see that that would be this branch right here? That's a homework branch. It ends in homework. Or this branch right here, it ends in homework. Those are the only two branches that end in homework. So what am I going to do with these two numbers right here? I want rain and homework. What am I going to do with them? What do I do with these? Multiply, multiply, multiply. On the branch, you multiply because it's rain and homework. So someone with a calculator, would you multiply 0.47 times 0.72 and tell me what that is?
0.3384.
Okay, Alana.
0.3384.
3384. All right, and then I need this one because I want all the homeworks. This problem says what's the probability of him doing his homework. So what's 0.53 times 0.12? 0.636. So what's this branch? This is what's the probability that it doesn't rain and he does his homework. Okay, now what do I do with those two numbers? I add them. The total probability of his doing his homework then. So let's say the probability of homework is, what do you get to?
So 40%.
What is it?
40.2%.
0.402?
Yeah.
And that's the answer to the question. Now, just for fun, would you find this probability right here and this probability right here? Do that on your own calculator, please. How do we find these? We multiply along the branch. So multiply those two, get an answer. Multiply these two, get an answer. Will, you too. You should get some random decimals here, right?
Yeah, I got, for the bottom one, I got 0.4664.
Okay.
For the top one, I got 0.1316.
Okay. Now, just for fun, would you add up all four of these numbers? Can you predict what's going to happen when you add up all four of those?
It's gonna equal 100.
It's going to equal 100. It sure is, because these are all the possible outcomes. There's nothing else that could happen, so their probabilities better add up to 100. If they don't, then something's missing somewhere, right? Okay, it's a little check for you if you're like taking a quiz and you got time to check. They got to add up to 100. All right, if mom fixes meatloaf, there's a 64% chance that she'll have potatoes. If she doesn't have meatloaf, there's a 45% chance of having potatoes. There's a 75% chance we'll have meatloaf. What is the probability we'll have potatoes? All right, so here we go. What does it kind of all hinge on? Meatloaf or not, right? So we're going to start with, we're going to have meatloaf or we're not going to have meatloaf. What is the probability? All these numbers are in the question. You just have to read it. What is the probability that we're going to have meatloaf today? 75%. Which means the probability that we won't have meatloaf today is 25%. Now, we're going to have meatloaf or not, and we're going to have potatoes or not, right? So if we have meatloaf, what is the probability we'll have potatoes? If we have meatloaf, the probability of potatoes is 64, which means the probability of no potatoes is 36. They gotta add up to 100 or 1. Now, what if we don't have meatloaf? If we don't have meatloaf,
45.
there's a 45% chance we'll have potatoes and a 55% chance
No.
we won't. What is the probability we'll have potatoes? Now that means we want to look at branches that end with potatoes. So what are we going to do right here?
Multiply.
Multiply. What do we get when we multiply? 0.48. And then we're going to multiply here. And what do we get there? 1375.
Wait, I got
Wait, no,
0.1125.
it's, yeah, it's point.
You guys.
1125.
We're just multiplying 0.25 times 0.45. What is it?
Point one.
Anaya, what is it? 1125. Is that one right?
Yeah.
So what is the total probability that we'll have potatoes? What are you going to do with these two numbers? You're going to add them. And what do you get when you add them? That doesn't equal 0.6.
0.5925.
5925.
Yes.
Number 4. What is the probability that we'll have potatoes and not meatloaf? So we'll have potatoes, but not meatloaf. Now wait a minute, what am I looking at? If we're gonna have potatoes and not meatloaf, wouldn't that be this number right here? So that would be 0.1125, because this is the potatoes and not meatloaf branch. What was this 0.5925? That was the total potato probability. So that was potatoes whether or not we had meatloaf. That's just total potatoes. This is potatoes and no meatloaf. All right, got one more of these guys. CHS buys bananas from stores P and Q. 70% of the bananas come from P. 90% of them from P are delicious, but only 80% of those from Q are delicious. So we're buying bananas that are either delicious or not delicious. All right, what does it start with?
Banana.
Like this one started with whether we had meatloaf or not. What does this one start with? Exactly, Tylen, exactly. Which store do I buy it from? So I can buy them from P or I can buy them from Q. What is the probability that I'm gonna buy my bananas from P? 70%. So 30% come from Q. Now once I go into the store to buy my bananas, they can be either delicious or not delicious. Right? How many delicious come from P? 90%. So 10% are not delicious from store P. What about Q? 80% and 20%. What's the probability I'll get a delicious banana? Aren't I looking here and here, kids, at the delicious bananas? So what am I gonna do? I'm gonna multiply. I think I can do that one in my head. And multiply. Double check my arithmetic. Those would be 0.7 times 0.9, 0.3 times 0.8. Is that right? Now what do I do with those two numbers? I want the total probability of being delicious. I'm gonna add them. So the probability of getting a delicious banana is 0.87. Now hang on to that because part B depends on that answer. So we need to remember what that answer is when we do part B tomorrow. All right, have a great day. I will see you tomorrow.